Rolling forging machines play a crucial role in the metalworking industry, facilitating the efficient shaping and deformation of metal materials through the application of compressive forces. This advanced mechanical process, known as rolling forging, is employed to enhance the mechanical properties and form intricate shapes in metals. At the core of rolling forging is the utilization of rolling mills and specialized equipment designed to apply controlled pressure on metal workpieces. The primary goal is to reduce the cross-sectional area and alter the shape of the material through a series of carefully orchestrated rolling passes. These machines are integral to the production of a diverse range of metal components, from simple rods and bars to complex profiles used in various industries. One key characteristic of rolling forging machines is their adaptability to different types of metals, including steel, aluminum, copper, and alloys. The versatility stems from the ability to adjust the parameters of the rolling process, such as temperature, speed, and applied pressure. The temperature control, in particular, can be manipulated to suit the specific requirements of the metal being processed, whether it involves hot rolling for higher formability or cold rolling for enhanced surface finish and dimensional accuracy. Hot rolling, a common application of rolling forging machines, involves processing metal above its recrystallization temperature. This method ensures easier deformation and improved mechanical properties, making it suitable for shaping large components like billets and slabs. Cold rolling, on the other hand, occurs at temperatures below the recrystallization point, resulting in increased hardness and surface finish, making it ideal for producing thin sheets and precision components. The precision achievable with rolling forging machines is a key advantage in the production of components requiring tight tolerances and intricate shapes. The consistent application of pressure through the rolling process eliminates defects and ensures uniformity in the final product. Additionally, the efficiency of these machines contributes to cost-effective mass production, making them essential in various manufacturing sectors. Rolling forging machines are designed in different configurations to accommodate specific applications. Cluster mills, tandem mills, and planetary mills are among the common types, each offering unique advantages based on the complexity and scale of the manufacturing process. Moreover, advancements in technology have led to the integration of automation and computerized controls in modern rolling forging machines, enhancing precision and allowing for more complex and customized production runs. In conclusion, rolling forging machines serve as the backbone of metal shaping in industrial processes. Their ability to accommodate various metals, precision in shaping, and adaptability to different temperature conditions make them indispensable in the production of diverse metal components across industries, ranging from construction and automotive to aerospace and beyond.